Here a glass prism is taken as shown in the figure. When a ray of light passes through a glass prism, it gets bent twice at the air-glass interface and then at glass-air interface. So as you can see in this figure, the ray of light PE is entering into the prism, and then as the ray of light is moving from the rarer medium to the denser medium, it is bending towards the normal, and when it emerges out of the glass prism, it is moving from the denser medium to the rarer medium, and the ray of light is seen to be bending away from the normal. So you can very well see that PE is the incident ray, EF is the refracted ray, and FS is the emergent ray. The angle of incidence is shown by angle I, angle of refraction is shown by angle R, angle E is the angle of emergence. The emergent ray is deviated by an angle to the incident ray, and this angle is known as angle of deviation, that is angle D. Now comes dispersion of white light by a glass prism. Whenever a beam of white light is passed through a glass prism, it splits into its component, and there is observed a band of colors. This band of colors is known as spectrum. As you can very well see in this figure, a white light is entering into the prism and it is getting split up inside the prism, which leads to the formation of band of colors, and this band of colors is known as spectrum. This whole process or phenomenon is known as dispersion of white light. So the spectrum of white light consists of 7 colors. They are violet, indigo, blue, green, yellow, orange and red. Vibgyor. The red light bends the least, as it is clearly mentioned in the figure, and the violet light bends the most. Next is recombination of the spectrum of white light produces white light. Here a beam of white light is passed through a glass prism, and as we have seen earlier in dispersion, that as soon as the white light enters into the glass prism, it splits up into its component colors due to dispersion. Now when these colors are allowed to fall on an inverted glass prism, you can see here one more glass prism is taken which is inverted. So when the spectrum of the colors or the band of the colors falls onto the second prism, inverted glass prism, it again recombines to produce a white light.
Dispersion of white light by a glass prism. Take a thick sheet of cardboard and make a small hole or narrow slit in its middle. Allow sunlight to fall on the narrow slit. This gives a narrow beam of white light. Now take a glass prism and allow the light from the slit to fall on one of its faces as shown here. Turn the prism slowly until the light which comes out of it appears on the nearby screen. What do you observe? You will find a beautiful band of colors. Why does this happen? When a beam of white light is passed through a glass prism, it split up into a band of colors called spectrum. This is called dispersion of white light. The spectrum of white has colors violet, indigo, blue, green, yellow, orange and red. Vibgyor. The red light bends the least and the violet light bends the most. Isaac Newton was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. When a beam of white light is passed through a glass prism, it is split up into its component colors. When these colors are allowed to fall on an inverted glass prism, it recombines to produce white light.